Okay, today we're having a look at the basic steps for solving equations. Whether you are a geometry student or an Algebra 2 student, solving equations is a skill that is absolutely just not going to leave us alone. So for whatever reason, if we got out of Algebra 1 or got out of Algebra 1 and Geometry and somehow still do not have this mastered, this is a problem we're going to have to solve. We're going to be solving equations pretty much from here on out. The math of geometry is Algebra 1, and of course Algebra 2 is simply more algebra. So we've got to figure this out. If you are hearing this or watching this at home, I'll walk you through how to take your Cornell notes, so please follow along. Of course, on your Cornell notes, the very first thing you're supposed to do is record an objective and a date. Okay, well, our objective today is the student will remaster the 5 steps to solving an equation. The video is going to go pretty fast, so if you feel the need, just press pause so you can copy down what you need to copy down, and then unpause it to move forward. So copy down your objective and the date. All right, there are 5 basic steps to solving an equation. I have boiled them down to as simple of language, simple of vocabulary as I possibly can. And here they are. You're going to need to memorize these, basically be able to recite them. And if you can get these guys memorized, then no matter how far you go in mathematics, no matter how difficult the equations get, you will have the basic structure in order to solve those equations. Sure, they'll get tougher. Sure, there'll be more things involved, but the basic steps will remain. The first basic steps is the first one I'm going to say is just parentheses. Now, there's other things that can be involved with parentheses, other restrictive items like brackets and curly braces, things like that. But just to keep it simple, the first word is parentheses. First step, parentheses. Step number 2, combine like terms. We'll talk more about this here in a minute, but the second step is to combine like terms. Step 3, your variable goes one way. Okay, we'll talk about that more here in just a second. Variable goes one way. Step 4, everything else goes the other way. Step 5, this is what I call the 1 and 1. And the 1 and 1, those numbers refer to, the first one refers to the coefficient of the variable, and the second one refers to the exponent of the variable. And what that means is the variable's coefficient needs to be a 1, and the variable's exponent needs to be a 1. In that order, we deal with the coefficient first, the variable second. Now, I came up with a goofy little way to try to remember this. So if you like cheesy things to try to help you remember stuff, here is one for you. If you can remember this little acronym, parents' complaints vary for everyone. I think everybody knows that to be true. Different parents gripe about different things. Parents' complaints vary for everyone. If you can remember just the first few letters of each of the words in that acronym, that'll give you a hint. Okay, parents, first word, parents, P-A-R, begins. Look at step 1, parentheses, P-A-R. Parents begins with P-A-R, parentheses begins with P-A-R. So if you can remember parents, hopefully that'll connect you to the word parentheses. Okay, second word, complaints. Complaints, first 3 letters, C-O-M. Look at step 2, combine like terms. First 3 letters, C-O-M. Combine, complaints, combine. Parents, complaints, parentheses, combine. Third word, vary, V-A-R, V-A-R. Third step, variable, goes one way. First 3 letters, V-A-R. Parents' complaints, vary, parentheses, combine, variable. Okay, then 4 is just kind of a little filler word to make the sentence make sense. After that, you get every, and you look at step 4, it begins with everything, else goes the other direction, then the final word, one, and the final step, 1 and 1. Parents' complaints vary for everyone. Parentheses, combine, variable, everything, 1. It's going to take a little practice, but there's just no getting around it. You're going to have to memorize these 5 steps. Okay, so if we can follow these 5 steps while following the rules we already know, we can solve most equations. Again, pause the video if anything goes too fast, and then press play when you're ready to pick it back up. Okay, now there's going to be other rules that are involved with solving equations, other things that are going to crop up from time to time. Okay, so what are these other rules that we also know about solving equations? First, guys, you've become way too dependent on using the calculator. Okay, unfortunately, has become a situation where we honestly believe the calculator is, for lack of a better way of putting it, some type of a god. We push the buttons on the calculator, and no matter what the calculator says, we write that down. We've simply got to do a better job of doing that. For example, if I were to say, okay, let's look at a problem everybody knows. Okay, what if I asked everybody, all right, what is the square of -3? Well, the first thing you got to ask yourself is, what does it mean to square something? Squaring something means to take that thing and multiply times itself. So if I say -3 squared, that means -3 times -3. We all know that 3 times 3 is 9, and a negative times a negative is always going to be positive. So -3 squared, absolutely, without question, is +9. Let's have a look at what the calculator has to say about it. -3 squared. Oops, I hit the wrong button. -3 squared. Okay, there's -3 squared. We all know it's +9, and the calculator says -9. Your calculator does not know something as simple as a negative times a negative has got to be a positive. Guys, this is a simple problem and an obvious error. You have got to be smarter than your calculator. And if you've gotten to the point where you turn to the calculator for every little thing that you do, okay, well, that's not going to work out very well for you. The math has become smarter than the calculator, and the calculator can no longer just hand you answer after answer after answer, and you just write it down. Okay, to put it in another example, if I gave you an equation, 2x equals 10, and asked you to solve for x, I think everybody would very, very simply tell me that x equals 5. We can look at that and common sense it to understand that x is 5. But even if you couldn't common sense it, we say, oh, I got to take x, I've got to divide by 2 to both sides, and that would mean that x equals 5. Let's have a look at what the calculator thinks of that, because some people, again, think that the calculator ought to be able to do everything for them, so they do things like go, okay, well, let me see what 2x is. Well, we already know that 2x equals 10. The problem says that 2x equals 10. What does the calculator think? Oh, the calculator thinks 2 times x is 40.85. And unfortunately, there's people out there that will simply copy that down, write it on their paper because the calculator said so. Well, guys, unfortunately, you'll hear me say it a million times, the calculator is only as smart as the person holding the calculator. If you don't know any math, then your calculator doesn't know any math either. So we've got to figure out a way to become smarter than the calculator. Okay, and the only way that's ever going to happen is for you to put the calculator down. Stop picking it up for every little computation that you have to do. If the calculator is meant to think for you, then it would do a much better job of thinking. Okay, all right, now on to the steps. First step, parents, P-A-R, P-A-R, that's parentheses. Okay, in parentheses, 99 times out of 100 mean that we have a distributive property that needs to happen. Okay, now the distributive property says, you've heard it before, if a value or a polynomial is multiplying by another value or polynomial, then each term from the first must multiply by each term from the second. Sometimes that is as simple as a number being multiplied by a set of parentheses, like you see over here on the left. 5 times x plus y minus 3. That 5 has to hit the x, it has to hit the y, and it has to hit the -3. Remember that that is a -3. Signs belong to the value that follows them. So that's not a +3, that is a -3. Okay, like on the second term here, we have a binomial, 2 terms, being multiplied by another binomial, 2 terms. Okay, well, the rule here is a polynomial times a polynomial. Every term from the first polynomial has to hit every term from the second polynomial. So the A has to go get the C and also has to go get the D. Once the A has gotten everything it can go get, then you scooch over and the B has to go get everything that it can go get. So the B's got to go get the C, the B's got to go get the D. Okay. And kind of the worst case situation is when you get fractions involved, like that example over there on the right. Okay, but basically when there's fractions involved with a distribution, it is simply two distribution problems that are happening at once. One of them happens in the numerators, the other happens in the denominators. So the x squared sitting out there on the left is going to go from it being in the numerator, it's going to distribute and get other numerators. So it's going to get that x squared that's inside the parentheses. It's also going to go get the negative 3y cubed, because the negative belongs to the value that follows it. Okay, the x squared goes and gets the negative 3y cubed. Okay, and then it's done. But then you also have denominators. The y squared in the denominator is going to go get the y to the first, and the y squared will then go get the m. How come the m isn't negative? Okay, typically when we see a negative sign, like we do right there in the middle of that binomial on the right side, usually positive and negative values with fractions, the positive or negative usually belongs to the numerator. Okay, so it's not like a negative numerator and a negative denominator, because if that was the case, you have a negative over a negative, they would cancel and become positive. This is not positive, it's negative. Okay, step 2, complaints. Complaints, C-O-M. The C-O-M is for combine like terms. Okay, well, in order to combine like terms, you better know when terms are actually like. Okay, well, there's 3 conditions that have to be met in order to add or subtract terms, and that's what you're doing when you're combining like terms. You are adding or subtracting. Okay, so first off, okay, you must have the same variable or the same group of variables. That must be true before you can combine like terms, the same variable or the same group of variables. If it's not the same variable or the same group of variables, do not combine the terms. They are not like. They will not combine, and if you do it, you just change the problem and you will no longer get to the right answer. The second condition that's got to be met is the variable or variables must have the same exponent or exponents if the exponents are a consideration. Okay, if they're not, don't do it. What this is saying is that x to the first and x squared, those are not like terms. You cannot add or subtract those because they have different exponents. So don't do that. On step C, or the third thing that you've got to have for like terms, is if you have fractions present, well, just like always, all the way back to 5th grade, you got to have common denominators. Now, unlike the first 2 steps, this one can be repaired. If you do not have common denominators in the problem, we can get common denominators so that the problem can then become like terms. So if you do not have the same variable, like step A, you're stuck. You can't combine. If you don't have the same exponents, like on step B, then you're stuck. You cannot combine. If you have fractions and the denominators are not common, you can fix that so that you can then combine the like terms. Okay. Once you decide that you have like terms, the only thing that you must do is simply combine the coefficients. The variable will stay exactly the way it is. So if you have 2x and you're trying to add it to 3x, well, 2x's, 3x's, when you add them together, that's 5x's. It's not x squared, it's not x cubed or any other crazy thing. You had some x's, then you had more x's, you put them together, they are still x's. Okay, now the last 3 steps, okay? Parents' complaints vary for every one. Variable, everything, and 1 and 1. Okay, the variable going one direction, everything else going the other direction, and then getting your 1 and 1 coefficient and exponent for your variable. These 3 steps are different from the first 3, or the first 2. And the reason that they're different is because these 3 steps involve sending things from one side of the equal sign to the other side of the equal sign. Okay, the first 2 steps were all happening just on the left or just on the right. Now things are switching sides of the equation. So here you go. In order to do that, you have to do the opposite of whatever the problem says to do. If the problem says you are adding, then to move it to the other side of the equal sign, you must subtract. If the problem says multiply, then to move it to the other side of the equal sign, you must divide. If something is being squared, then you need to think, what is the opposite of something being squared? Oh yeah, it's square root. So if it's being squared, to move it to the other side, you have to do the square root. Okay. And as always, the equation will stay balanced. It will stay true if you do the identical operations to both sides of the equal sign. If you want to add something to the left, you absolutely must add the same thing to the right. If you want to take the square root of the right, then you must take the square root of the left. There's no getting around this. If you break this little simple guideline here, B, you will unbalance the equation. The equal sign will no longer be true, and you will not get to the right answer. Okay. All right. Now here's what typically goes wrong. Okay. All the years I've been in teaching, this is what I see students do. These are your FAQs. Okay. First off, you've got 5 steps. Okay. You've got your parentheses. You've got your combining like terms. You're sending your variable one direction. You're sending everything else the other direction. Then you're getting your 1 and 1 coefficient and exponent. Will you need to do all 5 of those steps for every problem? And the answer is no. Okay, most frequently, the equations that you see usually only need 2 or 3 of the steps. Okay, it just depends on the equation. Whatever the equation needs is what we're going to do with it. So why do we have all 5 steps? Okay, it's a progression, kind of like order of operations. Please excuse my dear Aunt Sally. Parents' complaints vary for everyone. We think of the steps in that order. We look at the problem in that order. And if we can deal with those situations, if they exist in that order, we should get the right answers. Will you ever see things in a problem that are not mentioned in the 5 steps? You bet. Okay, like I said in the very beginning, I have boiled this down into the simplest terms that I can. The problem is with simplifying things, with kind of dumbing it down, that it becomes less specific. And less specific means you have less details. Less details means it's not going to explain everything. So you need to learn the steps, and then we will learn kind of what extra stuff also applies within those steps. Will everything you see in an equation have an equal opposite so I can move it to the other side? It's a little bit of a trick question. For this level, yes, absolutely. Okay, if something's being added, you can subtract it. When something's being multiplied, you can divide it. If it's squared, you can square root it, and so on. Everything in mathematics that we've seen so far has an equal opposite that will undo the thing we're trying to undo. As you go higher and higher into mathematics, you're going to see that there is some failure of this concept, that there are some things that you can do to a problem that cannot be undone. So some of the opposite operations, as we come to think of them, some of them don't work exactly the way we'd like to, but we'll get to that when the time comes. How will you know if you get the right or wrong answer? Okay. Typically, this is what you guys should be thinking. Check it. Check it, check it. Okay, when we get an answer, x equals 2, y equals 9, z equals -5, whatever the case may be, okay, check it, which is basically just, it's checking to see if the equation is still balanced. You started off with a problem that said something on the left equaled something on the right. And if we've done everything correctly, when we get to the end of the problem, the equation ought to still be balanced. Okay, so whatever we think the variable equals, we ought to be able to take it back to the original problem. Wherever the variable is in the original problem, pull that variable out, put the number that we believe the variable represents in, and simplify it. Simplify the left, simplify the right. If it says the same number equals the same number, 2 equals 2, 0 equals 0, -4 equals -4, stuff like that, then you plugged in a good number, the equation is still balanced, and you have the answer. But if you plug it back in and you end up with a statement that says something like 2 equals 3, well, the equation's unbalanced. Something must be wrong with the value you plugged in. Okay, there's a worksheet that goes along with this. It's basically practice problems, some simple equations that we need to be able to work. I want you to look at each of the problems on the worksheet, and I want you to think about them in terms of the 5 steps. Parents' complaints vary for everyone, and on each of those problems, I want you to recite that to yourself. Parents' complaints vary for everyone. Parents' complaints vary for everyone. I need you to get that programmed into your brain, just like you have, please excuse my dear Aunt Sally, programmed in your brain. If we can get that stuff memorized, we're going to be a lot closer to being able to solve equations correctly, accurately, and dependably.